Hello students, this is Mrs. Jones again. Today I'm talking about the binary system of numbers, and we're going to talk about how to convert from a binary system to a base 10, or what's called a regular numbering system, and back and forth. First of all, for those DC students, they might not know that the binary system of numbers is a base 2 numbering system. That means that there's only two different possibilities for characters in the binary system. And those two characters are 0 and 1. Computers do a lot of talking, maybe programming using the base 2 numbers. Inside of the base 2 or the binary system, there's a few definitions you need to know. One thing is called a bit, and it is just a single pulse, like a 0 or a 1. A byte is a grouping of 8 bits, so it would be 8 zeros or 1s put together in different combinations. A base and an exponent are mathematical terms. The base is, when you look at a power like this, the base is the 2 and the exponent is the 3, so this would be 2 times 2 times 2, which would be 8, right? Okay. The binary system has place values, just like our regular base 10 numbering system has place values. In our regular numbering system, if you think about place value, this would be the ones place, the tens place, the hundreds place, the thousands place, 10,000s, 10 or 100,000s, and so on and so on. Like if we had a number 4832, this would be the ones place, the tens place, the hundreds place, the thousands place. You understand that? So our base 2 numbering system also has place values, but the place values are 1, 2, 4, 8, 16, 32, 64, 128. Where those come from is that this is 2 to the 0. This is 2 to the first. This is 2 to the second. 2 to the third. It's always 2 because that's how many different characters there are. There's only 2 characters in the binary system. And then the exponents come from the position in the byte. Okay? So my very first little question here is, why is there no 2 to the 8th, 2 to the 9th, 2 to the 10th? Remember, we talked about our definitions up here, that a byte is a group of 8 bits. And if we count these, 1, 2, 3, 4, 5, 6, 7, 8, there's 8. There's no 9th or 10th place in a byte. Okay? How we do conversions with these, I'm going to grab my calculator, is I'm just going to teach you a very easy process. Okay, I looked at a couple other already pre-made videos online, and I just thought that they were going into way too much detail. If we set up a little chart like the one I have here with the first example, and we're going to convert the number 231 into a binary number. So what I want you to do with your calculators is that you would start with the number 231. I don't know if you can see 231. Okay. And you're going to ask yourself, from that, can I subtract 128? Yes, I can, right? 128. So I'm going to say, yes, I can. So I'm going to put a 1 there. When I do the subtraction, I get 103. So can I subtract the next piece? The next piece is a 64. Yes, I can. So I'm going to put yes, and then I'm going to do it. Okay. can I subtract the next piece, which is a 32? Yes, I can. So I'm going to go ahead and do it. Our next step is 16. Can I subtract 16 from what I have left on my calculator? No, I only have a 7 left on my calculator. Can I subtract an 8? No, I cannot. Can I subtract a 4? Yeah, I have enough here that I can subtract a 4. Minus 4. So, yes, I can subtract the 4. I put a 1 there. From what we have left on our calculator, can we subtract a 2? Yes, we can. And then what we have left, can we subtract the 1 that's left? Yes. So the binary number 1100 or 1110111 is the number 231 in binary code. Now if you had the binary number here and you needed to go back to the base 10, all you would do is add 1, 2, 4, 32, 64, 128. You would add those all together and you would get back to your 231. Right? Let's do another example. So here we're starting with 201. So I got 201 in my calculator. 201. Can you subtract 128 from 201? Let's try to slide this up here. Maybe you can't see it. Yes, so you can. So you put a 1 here and then actually do it on your calculator. See that? From what I have left on my calculator, can I subtract 64? Yes, I can. And then I'm going to actually do it. So I did that. From what I have left on my calculator, I cannot subtract a 32 or a 16, but I can subtract an 8. So I go minus 8. See, I'm just kind of letting things ride in my calculator. That seems to be the easiest. I can't subtract a 4, I can't subtract a 2, but I can subtract a 1. So why don't you guys go ahead and take a minute, pause the video if you need to, and try 122. This is what I got. And like I said before, if you had the binary number here and you needed to go back to the base 10 number, you would just add the 2, the 8, the 16, the 32, and the 64, and then would get you back to this 122. That is a good way to check yourself and to do the conversion the other way around. Okay? All right, thank you guys for listening. Go ahead and try the Google quiz and have a great day. Bye.